Ever wonder how AI models accidentally learn things they're not supposed to? Like what if a text-to-image generator started creating creepy images because it remembered bad data from its training? That's a real problem, and today we're diving into a groundbreaking solution called LoReUn. Let's start with the basics. Machine unlearning is the process of teaching an AI to forget specific information. Imagine a student who accidentally memorized wrong answers. Unlearning would help them erase those mistakes while keeping the rest of their knowledge intact. But here's the catch. Traditional methods treat all data equally. They try to forget everything at the same rate, even if some data is harder to unlearn. It's like trying to erase a sticky note with a sponge, inefficient and messy. Now here's where LoReUn shines. Researchers discovered something brilliant. The loss, a measure of how wrong a model is, can secretly tell us how hard a data point is to forget. Think of it like a report card. If a data point has a high loss, it's like getting a C grade. It's harder to unlearn. Conversely, low-loss data is like an A student, easier to forget. By using this insight, LoReUn dynamically adjusts how much weight each data point gets during the unlearning process. This is a game changer. Instead of blindly scrubbing all data, LoReUn focuses more on the tricky bits. It's like a teacher who gives extra attention to students struggling with a concept, while moving on quickly with those who have got it down. The result? A much more efficient and effective unlearning process. The team tested this on image generation models, like the ones that turn text into pictures. They found that LoReUn significantly narrowed the gap between approximate unlearning methods, fast but imperfect, and exact unlearning, perfect but super slow. This means AI systems can now better avoid generating harmful content, like inappropriate images triggered by bad prompts, without sacrificing speed. What's amazing is how simple this approach is. It doesn't require massive computational power or complex changes. Just a clever way to use the data's own report card to guide the unlearning process. And the implications? They're huge. From safer AI assistants to more trustworthy generative models, LoReUn could help build systems that protect users while staying efficient. So next time you see an AI create something wild, remember, behind the scenes, researchers are working hard to make sure those models don't accidentally remember the bad stuff. And tools like LoReUn are making that possible. But let's get technical. How does LoReUn actually work? Traditional unlearning methods often rely on retraining the model from scratch, which is computationally expensive. LoReUn takes a different approach. It leverages the concept of gradient-based reweighting. During training, each data point contributes to the model's loss. By analyzing these loss values, LoReUn identifies which examples are most entrenched in the model's knowledge. These high-loss examples are then downweighted during unlearning, allowing the model to forget specific data without disrupting its overall performance. Here's the clever part. LoReUn doesn't just randomly erase data. It reweights the importance of different training examples, focusing on the ones that were hardest for the model to learn. Think of it like a student who spends extra time on tricky math problems. LoReUn highlights the difficult parts of the data, making it easier to remove specific knowledge without knocking the whole system off track. Researchers tested it on datasets like CIFAR-10, tiny images of objects, and high-res tiny ImageNet, comparing it to older methods like RL and SalUn. The results? LoReUn boosted performance across the board. On CIFAR-10, it improved the model's ability to retain useful knowledge, called retention accuracy, up to 10% compared to other methods. And here's the kicker. It worked even when researchers didn't have access to the original training data, something previous techniques couldn't do. Plus, it's super efficient. The extra computational cost? Minimals. Just a tiny time boost, which is huge for real-world apps. Imagine training a chef to forget a specific recipe, but still cook delicious meals. LoReUn is like giving the chef a cheat sheet that highlights tricky steps, so they forget the old recipe but keep their skills sharp. Let's get concrete. In experiments, researchers asked LoReUn to forget specific image classes, like airplanes or cars. The model obliterated those categories in its output, replacing them with other objects. But the rest of its predictions? Crisp and accurate. It's like teaching a student to forget a single fact without messing up their overall knowledge. Why does this matter? For starters, it could let users delete their data from AI systems, fixing privacy issues. It could also help remove biases or prevent models from generating harmful content, like NSFW images or copyrighted material. Think of it as a digital delete button for AI, giving users control over how their data is used. As AI becomes more embedded in our lives, the need for responsible unlearning tools like LoReUn will only grow. This isn't just about fixing errors, it's about building trust. By giving models the ability to forget, we're taking a crucial step toward ethical, transparent, and user-centric AI. Thanks for watching. If you want to dive deeper into the research, check the links in the description. And don't forget to like, subscribe, and hit that bell for more deep dives into the future of AI. See you next time.